Hi, this is Alex from devstories.eu. OpenAPI and Swagger Ecosystem, Episode 10 of 19. You know what an integer is, but your database needs to know if it is a 32-bit or 64-bit value. Schemas bridge that gap. This episode is entirely about data types and schemas. The Schema Object acts as the rigorous validation engine for your API. It sits directly underneath your parameters, request bodies, and responses. Instead of just telling a client to send a generic JSON payload, a schema dictates the exact shape, type, and boundaries of that data. It acts as a strict filter at the boundary of your system. If an incoming request does not match the rules defined in the schema, it fails validation before your application logic even sees it. Historically, developers ran into a major point of friction when defining these rules. OpenAPI version 3.0 used its own customized dialect of JSON schema. It was close to the standard, but fundamentally incompatible in a few frustrating ways, causing endless tooling headaches. OpenAPI version 3.1 resolves this completely. It is no longer a custom dialect. OpenAPI 3.1 is now entirely aligned with modern JSON schema. Specifically, it acts as a superset of JSON Schema Draft 2020-12. This means any standard JSON schema document you already have is automatically a valid OpenAPI 3.1 schema. Being a superset simply means OpenAPI adds a few API-specific keywords on top, like XML configuration identifiers, without breaking the underlying standard. At the core of these schema rules is the type keyword. OpenAPI relies on the primitive data types defined by JSON schema. You have strings, integers, numbers, and booleans. The distinction between number and integer is strictly enforced. The number type handles floating point values and doubles, while the integer type specifically rejects anything with a decimal fraction. Here is the key insight. Knowing something is simply a string or an integer is rarely enough context for a back-end system. This is where the format modifier becomes essential. The format keyword narrows down a broad primitive type into something specific that your code can allocate memory for or validate against. The primitive type tells the JSON parser how to read the raw data, and the format tells your application exactly how to interpret the value. For example, if you define a property as an integer, you can add a format of int32 or int64 to specify its exact byte size. If your type is a string, you can apply a format like date, time, password, or email. The OpenAPI specification defines a standard registry of these formats, but the field is ultimately an open string, meaning tooling can support custom formats if your application requires them. Let us walk through a concrete scenario. You need to define a user object for a registration endpoint. You start by creating a schema of type object. Inside this object, you define two properties, an ID and an email address. For the ID property, you set the type to integer and the format to int64. For the email address property, you set the type to string and the format to email. Finally, you specify an array of required properties containing the names of both the ID and the email fields. You now have a strict executable contract. If a client sends an email property that does not resemble a valid email address or an ID that exceeds a 64-bit numeric limit, the API gateway or framework rejects the payload immediately. Precision at the API boundary saves you from writing endless data checking logic inside your controllers. That's all for this one. Thanks for listening, and keep building.